All right, guys, this is the second part of Indicator 28. Literally, this lesson is identical in format to the one in which we had done solving equations. The only thing different now is that we are going to have, instead of an equal to sign like we did in that lesson, in this we are going to have an inequality. And so then we'll have to solve it and then graph it, okay? So again, our learning target, of course, is the same because it's the same indicator. I can write an inequality that represents a real world or mathematical problem. And the real world, like I had told you before, that the airplane can carry at most 500 passengers, so maximum 500. Okay, so the inequality would be x is less than or equal to 500, and then you solve it and you graph it. Okay, so that's what we had done in part one. And then the next learning target, I can represent solutions to inequalities on a number line. So now we're going to solutions, and we are going to graph it on a number line. Okay. So if I look at my vocabulary, it is, you can see it's exactly the same thing like we had done in solving equations. We have the addition, like we talked about inverse operations earlier on. And so when addition undoes or subtraction, because it's the opposite. So the addition will undo subtraction, subtraction will undo addition, multiplication will undo division, division will undo multiplication, because those are inverse operations. Okay, so if I'm saying addition, property of inequality, basically if I am adding the same number to each side of an inequality, the inequality remains true. Okay, and subtraction property of inequality, if I'm subtracting the same number from both sides of the inequality remains true. Multiplication property is when I'm multiplying the same positive number on both sides of the inequality remains true. And division property is when I'm dividing the same positive number from both sides of the inequality remains true. Okay, so we have talked about this in equations, but the only thing now, instead of addition property of equality, now it has become inequality, because it is not equal to. You have several solutions. Okay, so let's go ahead and solve this. I'm going to show you a problem with subtraction. I'm going to show you a problem with addition, multiplication, division. Okay, so if I say solve x minus 3 is greater than 1. Okay, first you need to solve this, and then you need to graph the solution. Okay, so now I'm going to look at this. I just want to do a quick review. In the past, this is what we did. We did x minus 3 is equal to 1. So this is what we had done in the past. I'm just trying to refresh your memory. Okay, so when I saw whatever is attached to the variable is what I need to work on. So I'm seeing it's minus 3. And the opposite of minus 3 was what? Plus 3. So I was going to use the addition property of equality in this case, and I was doing plus 3 here. Whatever I do on one side of the equation of the equality, I do the same thing on the other side of the equality. So then I ended up in a previous lesson with 3 minus 3, opposites cancel each other out. X is equal to 4. Okay, and then when you had checked your work, all you had done was take the original equation, x minus 3 is equal to 4 and is equal to 1. And then I had substituted the value for x with 4, because x is equal to 4, minus 3 is equal to 1. And I had said 1 is equal to 1. So this is what we have done in the past. Now I'm just going to keep this here so you can see how similar this is. The only difference here is, instead of the equal to sign, I have the inequality over here. Okay, so let's look at this. And all right, so this is again x minus 3. So we are looking at what is attached to the variable. It is a minus 3. So the inverse operation would be plus 3. Okay, so we are going to use the addition property of inequality now. Now, it's not an equality anymore. It is an inequality. Okay, because it's not balanced. One side may be more than the other. One side may be less than the other. So it's an inequality. Okay, so now we are using inequality. So I am going to add 3. Whatever I do on one side of the inequality, I have to do exactly the same thing on the other side of the inequality. And so when I solve this, I end up with x is greater than 4. Okay, x is greater than 4, and that is my solution. So look, it's the same thing what I've done over here, but only thing what is different, this is not an equal to sign anymore. This is an inequality. Just want to show that to you, just so that you understand that the lesson is identical in format, with the only difference is the equal to sign has been changed to an inequality. Okay, and now we're going to graph it. So if I graph this, remember we said the first thing you need to do is give values. Okay, so if I'm looking at x over here and I'm thinking it's saying greater than 4, so what number is greater than 4? 5, right? So 5, 6, 7, and these are all numbers which are greater than 4. So if I'm saying greater than 4, I know that because it's a bigger number than 4, my graph is going to go to the right. Okay, so I'm going to make my graph, and I can just start at 4. It doesn't matter. If you want to start at 3, that's fine. 4, 5, 6, 7, 8, and so on. And then since it is greater than 4, but 4 is not included, it's not saying x is greater than or equal to 4. Since 4 is not included, it is going to be an open circle. Okay, we're going to go to 4. We are going to make an open circle, and all numbers to the right of 4 are going to be a solution to this inequality. Okay, so this is how you show this after in a graph format after solving this inequality. All right, let's go ahead and do one with addition, where we'll have to use the subtraction property, okay, of inequality. So let's do one problem like that. Let's say I give you, the problem is 15, I'm going to erase this. Okay, so if I say 15 is greater than or equal to 6 plus x. Okay, 6 plus x. So now when I look at this, either you write 6 plus x or write x plus 6. Remember, addition has the commutative property. It means the same thing. But you cannot do that with subtraction, okay? But anyway, if I have 6 plus x, I'm looking at what is attached to the variable. So what is attached to the variable? It is, if there is no sign in the front, what does it mean? That means, and we've done this before, it means it's a positive number, okay? So opposite of addition is going to be the subtraction property of equality, because this is addition, okay? So this is going to be the opposite of addition is my subtraction property of inequality, because this is an inequality, okay? So now when I look at this, okay, since this is plus 6, opposite of that, we are going to do minus 6. I do minus 6 over here. Whatever I do on one side of the inequality, I have to do the same thing on the other side of the inequality. Okay, so here we get 6 minus 6. We are left with x. All right, and then we have greater than or equal to 15 minus 6 gives me 9. Okay, so now it's saying the solution is 9 is greater than or equal to 6, I can write it this way. Or I can also write it this way. X is less than or equal to 9. Both, it's the same thing. Okay, but remember you will have to flip this also if you are putting this. Just see where the mouth is opening. That is the greater number. Okay, so now I'm going to make my number line. But before I put any numbers on it, I have to think of, okay, it is equal to 9. So because here we go, so 9 is definitely included. And then it is saying it's less than 9. So if it's less than 9, that means a number less than 9 would be 8, 7, 6, and so on. So if it's a smaller number, we know that it is going to go to the left on the number line. Okay, so I can just write over here 10, 9, 8, 7, 6, 5, 4, and so on. And then since 9 is included, this is, because 9 is included, this is going to be a closed circle. Okay, so this is a closed circle. We are going to completely color it in. And then every number to the left on the number line is going to be a solution to this inequality. All right, so just wanted to show you the addition subtraction, and now let's go on to multiplication and division. Okay, so if I give you a problem in which it says if I have a problem that says x over 5 is less than or equal to 2, please remember the fraction line means division. Okay, so opposite of division is going to be multiplication. So we are going to have to use the multiplication property of inequality when we are solving this one, because opposite of division is multiplication. You are free to write it like this also. Okay, you're free to write it like this also. Okay, and we've also talked about this before. So you can either write it like this or this way. I'll show you both ways. Okay, so now what is attached to the variable? What's attached to the variable is 5. So 5 is the number that I will have to multiply on both sides of the inequality. So I'm going to do times 5, okay, times 5. And we know that this can be written like this, okay? And since it's a fraction, we can simplify anything from the numerator to the denominator as long as we have that multiplication in the middle. So 5 divided by 5 gives me 1. And 1 times x is going to give me x, because that's the thing about multiplication by 1. Any number times 1 is the number itself. So 1 times x is x, because x is representing a variable, a number, okay? And then x is less than or equal to 2 times 5, which is 10, okay? You could have done the same thing here. You could have just done times 5 times 5, okay? And then we know that multiplication division will cancel each other out, and so x is less than equal to 2 times 5 is 10. So I don't care how you show it to me, both mean the same thing, but now graphing is the big one. If I make out a number line, it's saying x is here equal to 10. So 10 is a value. Do not forget to put these values, okay? And then it is saying less than 10. So then we think about, okay, if it's less than, it's a smaller number. So 9, 8, and always look at this and say, hey, is 9 less than 10? Yes, it is correct. Is 8 less than 10? Yes, it is correct. So that way, you know, if it's less than, it's going to go to the left. Because by mistake, if you put the arrow to the right, then you're thinking, hey, 1 minute. How is 11 less than 10? How is 12 less than 10? No, that's not correct. So that is why make sure that you put these numbers so you know in which direction your graph is going to go, left or to the right, okay? So I can just put 10 here, 9 because I'm going to the left. I know these numbers are smaller. So I can just do this. And I know that 10 is included. So this is a closed circle. And then every number to the left is going to be a solution to this inequality. It's going to make the inequality true. All right, so this was using the multiplication property of inequality. And then let's go and do the last one, which is going to use the division property of inequality. Okay, so if I say, the question is 4n is greater than 32. Remember, we've talked about this over and over and over again, that when a number is written next to a variable, that is the coefficient of the variable, and that means multiplication. So now, opposite of multiplication is division. So we are going to use the division property of inequality. Okay, and so since I have 4 over here, which is attached to the variable, I'm going to divide both sides by 4. So let me just write this down so you can see what I'm doing. Okay, now division you can show either as a fraction line where you're dividing 4 by 4 or 32 by 4, or if you wrote it like this, if you wrote it like is greater than 32, and if you wrote divided by 4 or divided by 4, that is both perfectly fine. Okay, and so when I divide 4 by 4, I get 1, and 1 times n is n, which is greater than 32 divided by 4 gives me 8. Okay, same thing here, you could have done that, 4 and 4, you know, the multiplication division cancel each other out, n is greater than 8. Okay, so now, once you have n is greater than 8, and before you solve it, make sure that you are giving the values so your arrow on the graph goes in the correct direction. Okay, so it's not saying is equal to 8, so 8 is definitely not part of it. Then I think of what could be greater than 8. Well, 9 definitely is greater, 10 is greater, 11 is greater, so that means all the numbers on the right. And anyway, if it is greater, any number that is greater is to the right on the number line. Okay, so I can do 6, 7, 8, 9, 10, 11, 12, 13, and so on. Okay, since 8 is not included in it, this is going to be an open circle, and then all numbers to the right are a solution to this inequality. All right, so this concludes indicator 28, and this concludes our unit 7. So all about equations and inequalities. It's really simple. Just be careful, do these simple steps that I'm teaching you, and you will not go wrong. All right, guys, have a wonderful day.